first, I think it would be wrong to not first talk about a bit of history in terms of how we got here to TXT. And, you know, I also wanted to talk about, for people who might be just joining in or might be either new to Bitcoin development or maybe just new to the Planaria tools in general, I also am just going to touch a bit on our core suite of APIs, and then finally leading into sort of how maybe the future, possible peer-to-peer future, and how TXT fits into that. So that's the plan for today's presentation. And yeah, do want to encourage, if you do have any questions, write them down or ask me afterwards, or even if more questions come up later down in the day or while you're developing, I'll be available on Slack pretty much during the weekend. And so just reach out to me, and I'll be happy to answer, whether that's after the presentation today or later on. So well, let's dive right in. So the first thing I want to talk about, back, like I said, is just a bit of history. So first, like a quick timeline about like kind of how we got here. So first, we really have late 2018. That's when some of the early tools are being developed, which focus on building Bitcoin data-based applications, and along with a few kind of I have listed here kind of unfuckings of the Bitcoin protocol. We start seeing really rapid growth of the Bitcoin application ecosystem. And so many of these applications that are being built are built on open source tools. You know, some of which, as Steve mentioned earlier, were developed by Unwriter. And but yeah, the point here is that a lot of them are kind of, that's what they are. It's just is tools, and they do enable this really rapid growth. And so you might recognize some of these tools. Maybe you are still using some of them. So that would be like Neon, Kronos, Genesis, Bob, DataPay. But you know, coming up into the period of July 2019, that's really where sort of we notice a need for sort of a shift to happen, and that's and that shift is what we start seeing is following the growth of applications. We see a rapid increase in the rate of growth of data that's going on chain. So so what this means is that we know it's time that, you know, the services, the infrastructure which is powering these applications, also need to professionalize and get ready to scale to handle the future demands. So that leads us to part 2 of the timeline. So September 2019, that's around the time Planaria Corp is formed, and this is all leading up to February 2020. You know, I know the Node team was doing a ton of work to get ready for Genesis, but behind the scenes, so were we, because there were, you know, providing filtered data from the blockchain. We know what kind of future challenges we'll have at real scale. And so leading up to February 2020 with the BSV Genesis upgrade, that was also February 2020 was also a big moment for Planaria, where we released our, what we call the grid. And what the grid is it's our core suite of APIs, which I'm going to talk a little bit about that later. And then finally, leading up to you know, June and July, of course, the BSV DevCon. Well, recently we you know, we've also want to focus on giving application developers as many choices as possible. So while we want to build fully Bitcoin derived applications, we also fully peer-to-peer applications. And so we're going to lead into how TXT really fits into all that. So I'm going to go ahead and move forward. So the grid. So what is the grid? Well, the grid is our, like I said before, our suite of stable and scalable APIs, which we are going to support into the future as Bitcoin grows. And so this is really a triad of APIs. So Bitbus, Bitsocket, and BitFS. Bitsocket for listening and filtering in real time, Bitbus for querying, and BitFS for large data. And so I'm going to do like just a quick sample on each of these three. And for some, this may be a review. For others, this might be new to you. But like I said, if you since I'm going to kind of go real quickly, if you have any question or words, but hopefully this will be a good introduction and at least let you let you have an idea on what the tools you have at your disposal. So first, I want to interrupt that and do a quick review of what TXO is. So TXO is essentially it's transcription and translation of Bitcoin transactions into a format that can be indexed and queried. So so TXO has really two parts, two levels to it. So one is the transaction level. And so here you have items like the transaction hash, the block height index, the block hash. You have your input array, your output array, end lock time, and timestamp. At your next level is going to be your script level. So you're going to have your input, output attributes. So in each of those input and output arrays, you have your script level, and so within that you have the input, the index within the transaction. So that will be the topological ordering, sequence, edge. S attributes would be string, B is base 64, H is hex. So and then length. So again, I'm not going to go too deep into this. Oh, and another quick thing to mention that's not included here at transaction level is I is also included. So with Bitbus, you have the I attribute. So that's topological ordering within the block. So, but moving forward, and the only reason why I cover that is because it's relevant for what we're about to show, and so that is to make it possible to use BitQuery, which is a Bitcoin query language. And so it's really simple. It's basically if you're unfamiliar with it, if you're familiar with MongoDB's query language, then it's pretty much the same with a few added features, and really it's a small learning curve, so you can really jump right in. So anyways, moving forward, so Bitsocket. So Bitsocket is used for listening to the mempool in real time. So and Bitsocket order is based on timestamp. So let me just jump into a quick example of how we can use Bitsocket. So Bitsocket uses a Git-based API, and so like I mentioned BigQuery earlier, what you can do is you subscribe to BigQuery and then from the mempool in real time as the transactions hit. So let's give an example of what that looks like. So like a simple, the most basic BigQuery you can really have is just empty find. So yeah, let's give this, make sure that's all good. So this would be like a super simple BigQuery filter. And so what we're just going to do, just to demonstrate this, is we're going to just transform it to base 64. Okay, and then what we're going to do is I'm just going to use curl to demonstrate the APIs, because most of the time, I mean, you can use whichever language you want. That's what's great about having pure API based. But yeah, I'm just going to use curl. So HBS TXO. So and the socket endpoint uses /s. We also have a query endpoint where you can actually query that for the past 24 hours from the Bitsocket database if you're worried you might have missed something. But again, like these are things which we can talk about more later. So here would be curling the. So what we see here is just transactions kind of as they're hitting the mempool. So ordinarily, you can imagine how you would use this is you would instead of having an empty find query, what you might do is you might include your bitcom here, your bitcom, and that's how you would use this to kind of to know when transactions are relevant to your application are hitting the mempool in real time. So that's my quick Bitsocket example. Now moving forward to Bitbus. So Bitsocket. So you want to know as soon as something hits the mempool, but it's not really real. It's not really. It doesn't really have a place in time really until it comes into a block. So if you want to basically, if you either want to sync with on-chain or kind of ever want to resync your application, you can use Bitbus's crawl or query endpoint. So we'll do a quick example of this as well. So let's do. Okay, so what I have here is let me just first just show you what we're looking at here. So this is another just curl example. So where Bitbus uses the post API. So first off, to use Bitbus, you will need a token. So I have a token prepared here, but ordinarily, if you want to fetch that token, what you'll do is you'll just go to Wolfe of Planaria network. It's really simple, and you'll come here and yeah, you'll just copy this down and that'll be it. But you generally, you're not going to want, unlike me, you don't want to usually screencast that. You want to keep that private. So anyway, so you'll include a token in header, and you'll want to let content type know application JSON, and then finally data. Again, this is going back. This is using BigQuery. So you'll use a filter which you want, and you will need to include with Bitbus. You will need to include a limit, because obviously we don't want you to basically request the entire blockchain. So you will need to include a limit on that. And then here I'm just piping it to JQ just so it looks prettier when you see it. So what I'm going to do here, actually, is get rid of this. So what we're looking at right here is just a BigQuery for the B protocol. So for those that are familiar with the B protocol, and limit one. So I just this just returned and I didn't include a sort on this. So this just returned we crawled transaction. Looks like this one is from block 572,561. Here's your different attributes. Here's S0, so that's going to be a string. This is chunk index 0 for input array index. Looks like input array index 2. And anyway, so this here's your Bitcom. So this is what you're going to use to query. So moving into a BitFS. Well, BitFS is for large data. So BitFS is meant to work in tandem with Bitsocket or Bitbus. So obviously, with people now posting all kinds of files and images, all kinds of large data on the blockchain, well, oftentimes, these large data can't be fit directly into an index, but instead what we do is we include references to that large data in a deterministic fashion. So going back to this query, adding back in what I had before, we're gonna make sure that out.f3. So what I'm doing now is I'm including a filter for F attribute, and F attribute is used for BitFS. That means file. F stands for file, and again, the numerical is the chunk index. So that's the chunk index within the script. So what I'm doing now is I'm making sure that F3 will exist, and we're just going to get 1, and I'm going to use this one for a demonstration. What happened there? F3. What do I do here? It's here. Okay, I'm gonna show you this way. I'm gonna waste time with that. So essentially, we do have an explorer. So the way this works is basically it's ordered by transaction out, and then output index, and then chunk index. So we can go to these pictures here. So so like if let's say you have a bit, like you're filtering for your bitcom, and you see a f attribute, and you want to basically store that f attribute into a file on your server. Well, okay, then what you would do is let's take this guy. So our file API is x.bitfs.network, and then you have the transaction, output index, and then chunk index. So all you would do here is curl that, and then let's say file. Okay, open file, and you can have that on your server. So anyways, don't want to waste any more time with this, but you get the picture. So moving forward to part 3, which is the peer-to-peer aspect. So everything I've discussed so far has been kind of up till a few months ago. A lot of the core of Planaria was about fully Bitcoin derived applications. And while this approach has some really powerful advantages to it, we do want to give the developers as much flexibility as possible, and part of that is there is a need for peer-to-peer, and this has a big part in the future. And so to allow developers to work with that, we built TXT. So what TXT is it's basically it's a big transactional database, and it works as sort of like it basically is a database management system for which is tightly coupled with Bitcoin, and I'll explain what I mean by that. So TXT. So again, so what it does, it does semantic Bitcoin storage, but what it is a Bitcoin transaction DBMS. So let me first kind of unpack that a little bit. So TXT as a Bitcoin transaction database management system. So you might have heard of database management systems. You might have heard of these or even worked with them before. So an example of this would be Microsoft Access. So many of these popular database management systems have database applications which go with them, but you don't necessarily the built-in database application to use database management system. TXT is much the same. TXT makes it extremely simple to just get started building peer-to-peer Bitcoin transactional databases, and it has a nice built-in database application, which is where you can search and kind of explore. But you can basically build your own database applications on top of that, or on instead of that, for your users to interact with. So I don't have time to explain all the details of how TXT works, but I do want to give an example to just demonstrate the power, and a lot of that power lies within the end game here, which is the SQLite DB as a file. So this means that the databases generated by TXT in the spirit of peer-to-peer are literally files. So they are so portable. I could email this as an attachment, or I could literally just send it back and forth. And so this is really where a lot of the power of TXT lies. So to demonstrate this, I'm going to show an application that Unwriter recently released called BitCache. So what BitCache does is it basically exposes a wrapper around the TXT API, which enables you to which lets you easily subscribe to query Bitbus, pipe that into your TXT database, and then subscribe to a Bitsocket query to continually listen and write that into your TXT database. Meanwhile, and then you can basically share this share this as a file. So let's explore that real quick. So TXT, to use TXT, you do need two things. And then I'm going to use the Docker Compose just because this is just so I can it has inbuilt like the mount functionality for Docker volumes, which you don't worry about right now. But yeah, so you will need Docker. So what I'm going to do is I have my Docker Compose file here already. If you want to get that Docker Compose file to try TXT, first just install Docker Compose, and then just curl txt.network/docker compose.yaml .yaml, and then write that into a file, and then you'll have it right there. I already have mine set up. At least I think I do. Or maybe I don't. Yeah, so anyways. curl-l. I not have it? /docker compose.yaml docker compose.yaml. Okay, so now I do. Okay, so here's what that looks like. Basically, I'm not going to spend much time on that, but now we're just going to do, first I'm going to get rid of that mount folder. And Docker Compose, okay, so what I have here now, this is just a so I'm just gonna go to localhost 3013, and what this is now is this is an empty TXT. So mentioned back here, back at this graph, this is what we're looking at. And so, like I said, TXT comes inbuilt with a database application, but the core of TXT is really in the database management system and the API that it exposes. So to demonstrate this API, first we're gonna try this BitCache example. So what I'm gonna do here is this is a BitPick cache. So what we're gonna do is basically we're gonna crawl all BitPicks using Bitbus, and then subscribe to a query which I like, similar to what I demonstrated with Bitsocket, to listen for new BitPicks coming in, and we're gonna write these all into the TXT database. So let me run this. So we'll be able to see this thing pop. Yeah, so we see this thing populating pretty quickly. And within, let's see, all right, so what's happening now is BitPick, yeah, is pushing all these BitCache is querying that, basically crawling Bitbus and pushing all of those into TXT. And yeah, we see these basically populate here, and I think this should be pretty much like, let's see, like Ryan at moneybutton.com. Yeah, so this is all here. So what we're going to do now is, since that's basically done, and the other advantage of BitPick is it works with the miner API. So what it'll do is it'll once you push all those transactions in there, it'll also crawl the miner API. You can see this happening now. It'll crawl the miner API, and it'll request for the confirmations on those transactions automatically. So that's pretty powerful. So you can basically have a signed proof from a miner, where this transaction actually exists on chain, or if it doesn't exist on chain. So TXT is pretty agnostic to that. So now what I want to show you quickly is if I go into this mount folder, txt.db. So txt.db, this entire BitPick DB is 2.3 megabytes. So if I wanted to, I could simply take this file and everything's here. My entire DB is here. So here's all the transactions. We see the data that goes along with it. Meta tags. So here's the money button users. And so you with TXT, you own your database. So and it's the portability is really critical here, where if we want to facilitate a peer-to-peer environment, the databases themselves have to be able to be shared easily. And so that's what TXT does. And so finally, next thing I want to touch on is sort of, I do want to give a quick plug to, we have a new mental approach for peer-to-peer, which is called Palping. And this is really a new approach to doing peer-to-peer, taking it really to the extreme. So I encourage you to check this out. We'll be releasing more about the Palping protocol in the future. I'm not going to say too much about it right now, other than that, you should go check it out. So let's see, that's about it for me. And so let me go back here. I want to leave some time open for, not leave. All right, yeah, I want to leave some time open to kind of just talk and answer questions. I'm not sure how much time I got left, but yeah, that's everything I wanted to quickly cover. And so yeah, now I'd like to see if there's any questions, and just talk.
Thank you, Glenn. We've racked up a few questions here so far, so let's crack on.
Yeah.
Edfrit asks, is Planaria planning to work on indexing and searching specific types of smart contracts, for example, R puzzles, and and then he says script hash is not enough. Oh, okay. Searching by script hash is not enough. He wants more granular indexes.
Yeah, we are like going to continue to evolve our index structure. So it's not set in stone. So I mean, we know that with we're really excited about Scrypt, and yeah, all I can say is I can't give any details on what exactly the future plans are, but yeah, I'll say we will do whatever makes sense for the community and what people want. Yeah.
Cool. So next question, I think probably goes to that, and it's a really pertinent one because it gives a bit of a hint about which direction you guys are going. How does the back end of Planaria make use of SPV, or actually even does it make use of SPV? Is it going to use SPV, or do you envisage Planaria running a Terranode to provide whole or blockchain type query services?
Yeah, we don't want to compete with miners. So we want to work kind of in cooperation with SPV. So that, like, sort of the beginnings of that are the miner API services. So like with TXT, for example, has a flexible miner API. So it's kind of like you get to choose your miner. So we basically want to, our goal is to facilitate basically the way that miners engage. Like, for example, for SPV services, we want to help facilitate the process of how miners actually engage with applications. in whichever way we can. And so the beginning of that would be, you saw the, starting with Minercraft and then now moving to like how TXT kind of automatically crawls that miner API to check where if those transactions exist. Services like that, that's kind of where we see our place in the future.
Yeah. I think it's important to note that there's probably a role for multi-layers of data indexes. Miners, of course, have the entire blockchain because they have to in order to do their job. And so that's a natural place to do sort of some level of distribution or selective distribution to different clients. That's not to say that other parties who aren't specifically involved in mining can't play a role in that filtering and distribution. And in fact, I'd say a lot of the Planaria services kind of fit into that space right now because they're essentially query services. And what good is a query if you're not confident that you're not missing results? But it will be fascinating to see how that does evolve as we scale up, and Planaria has to consider the economics of at least having a look at all data, even if it doesn't keep it all.
Just like a note on that, right now with Bitbus, you can basically, you can go back to around like block like 560,000. It could be in the future where part of the reason, if you think of like even the name Bitbus is that it sort of is like it should be really looked at as like a synchronization engine where maybe there's an interval. We don't know how it'll look in the future, but it could be where you sync with Bitbus, just like Bitsocket has a 24-hour interval of what we keep inside of the Bitsocket DB. It could be that with Bitbus, that at scale that interval could shrink, and it could be up to the applications to probably will be up to the applications to store what's relevant to them. But we want to at least make sure to keep providing. We think like providing an index layer is really important at the moment.
I think for anybody that's relatively new to the Bitcoin SV space, trying to understand the data model, studying the different products in the Planaria suite is actually a valuable exercise, because you'll notice things like, for example, sorry, it's not Bitbus, the second one that you mentioned. Only keeps 24 hours worth of data.
Bitsocket, yeah.
Only keeps 24 hours worth of data, and at first that seems like a limitation. Well, why not just have a product that offers all of the data as opposed to another product that's or having to use a different one for a different thing. But if you stop and think about the reasoning why those individual services have those kind of individual restrictions, it's because they're intended to be used in certain ways where those restrictions don't matter. By getting your head across those sort of different usage scenarios, it really helps to understand the different ways that people can make use of Bitcoin SV. So Anonymous asks, how does TXT relate to TXQ? What are the differences and similarities?
Yeah, I'll say they're pretty similar. I think you should look into it. Just look into the documentation, and I think you'll be able to answer that for yourself, I think. So yeah, that's all I'm going to say on that.
Okay. Konstantinos asks, okay, it's a question. Today's databases like Postgres, do they become 100% unnecessary with something like TXT?
I'm not. I don't. I mean, there's. So TXT uses SQLite, and we did this purposefully because, the peer-to-peer is all about portability, really. So I mean, if you want to create payment channels, you need to be able to share, easily send and share these channels. And so that's an example of why we thought that SQLite was the way to go. And but that being said, things like Postgres SQL, you may have there's different reasons why you'd want to use a different types of databases depending on your application. So I wouldn't necessarily say that, but I think for the P2P ecosystem, right now we thought that SQLite was the right decision. So.
Okay. We've got a question here about Palping, which has arrived fairly recently and seems to be attracting quite a lot of attention. And I think they're talking about the decision to hold transactions off-chain. Will you post Merkle routes of all of the offline Palping transactions to the blockchain?
So what I'll say is in the next week or so, coming weeks, we will be sharing more about what the future of Palping will be, and this is really an experimental approach for us, and we really want to test what peer-to-peer can mean and does mean, and so specifications about the protocol will be, I don't want to talk more about it until we're ready to kind of formally announce it.
Okay, we won't try to nail you down too soon. Well, while you're here, actually, a question I've seen pop up on Palping a few times is what is the correct verb? On Twitter, it is to tweet. On Palping, it is to something. So I think we might as well ask an authoritative source while we're here, while we've got you.
Yeah, well, I mean, you tell me, Steve. What do you think? What should it be?
I'm guessing Palp, but that's kind of awkward to say. So.
Yeah, I mean, I'll go with well, I mean, I think we'll let the users decide.
Okay. Last question here from John Pitts. Can TXT or anything in Planaria toolset mimic the advantages of a relational database? SQLite is actually a pretty rich database and a basis for most iOS apps. So TXT plus Oracle. Not quite sure what that last part means, but
yeah, I don't. Yeah, I think. I mean, SQLite is. I don't really quite understand the question. I'll say I think the advantages of relational SQLite really is a relational database. So I mean, I'm not really sure where he's going with that, but I guess as a final, you mentioned something earlier, like when you were talking about a Bitsocket, and I think like one of the points that I think I wanted to be clear about is like our goal is really to give developers as many choices as possible. So you may like while it seems like peer-to-peer is somewhat conflicting with our whole ideology, like up until the point of TXT, everything we built was based off of deriving from Bitcoin itself. But we want the developers of the future applications to decide the infrastructure of the future, and so whichever way that goes, we want to make sure to provide them with the best tools. And so yeah, really our goal here is just to give you guys who are building good options, and everything that we presented today. I know I didn't have a lot of time to explain it or give kind of a detailed explanations, but I will say inside of the presentation there are links to each one where you can find documentation, and most of the documentation is pretty thorough. And if you have questions after that, like I said, I will be on Slack, and I'm happy to answer questions. And yeah, so I just wanted to get that out there, and that we are really looking to you guys to grow this space, and yeah, we want to assist you the best way possible.
So maybe when devs have figured out features that they want and need, they can palp it to you, and
yeah,
then unwrite it, and you guys in the team can deliver.